GCSE Chemistry. Welcome. Are you excited for a fun learning session? Make sure you have your book and a pen before we start. Today you are going to learn about the factors that affect the rate of reaction. Factors affecting the rates of reaction. In order for a reaction to take place, if reactant particles collide with enough energy, the minimum amount of energy necessary for a reaction to take place is known as the activation energy. The more frequently particles collide, and the greater the proportion of collisions with enough energy, and therefore the greater the rate of reaction. There are 5 factors that affect the rate of a reaction. These are temperature, concentration, pressure of reacting gases, surface area, and the use of catalysts. If the concentration of a reactant increases, then rate of reaction increases. This is because as concentration increases, there are more particles available to react in a given space. When there is a low concentration, the chances of the 2 reactant particles colliding is lower compared to the higher concentration. If the concentration of a reactant increases, then the rate of reaction increases because there are more reactant particles in a given volume, and so the particles are more likely to collide. If a solid reactant is broken into small pieces or ground into a powder, its surface area increases. This means that more particles are exposed to the other reactant, there are more collisions, the rate of reaction increases. When the reactant is in a block, there are fewer surface particles for the other reactant to collide with. When the block is cut up, there are more particles available to react. If the surface area of a reactant is increased, then the rate of reaction will increase. However, the reaction will continue until the reactants are used up, so the reaction will end at the same point. If the temperature of the reactants is increased, then the reactant particles move more quickly. This means that the particles have more energy, the particles collide more frequently, and therefore rate of reaction increases. When the temperature increases, the particles have more energy and so move more quickly. This means they collide more often. As the temperature of the reactants increases, so too does the rate of reaction. If the pressure of a reacting gas is increased, the same number of particles are now in a smaller space, or more particles have been added to the same volume. This means that the reactant particles are closer together. There is a greater chance of the particles colliding. Therefore, the rate of reaction increases. If more particles are added to the same volume, then the pressure increases. If the same amount of particles are placed into a smaller space, then the pressure increases. As the pressure increases, the particles of the reactants are closer together, and so they are more likely to collide. This means that the rate of reaction is faster. This can be seen as the gradient of the line is steeper. A catalyst is a substance that can increase the rate of a reaction without being used up itself. Common catalysts include an iron catalyst used in the Haber process, and platinum catalysts used in cars. The addition of a catalyst speeds up the rate of the reaction, so the line is much steeper than the rate of the reaction without the catalyst.